Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study how to draw a displacement diagrams of a cam profile when the angle of rotation at the various angles and the lift of the follower or the follower is having a motion during outstroke is one type of motion and the return stroke is another type of motion or another kind of motion. So, going to take a case study during return outstroke, the rotation of the cam, the angle of rotation of a cam during outstroke is 120 degrees and next to outstroke is 60 degrees of cam rotation is the dwell, and next to 60 degrees of dwell there is return stroke, that is 90 degrees of cam rotation, and the rest of the angle is the dwell. Now if the follower is having a motion of uniform velocity during outstroke and return stroke is uniform acceleration and retardation, then how to draw a displacement diagram? Uniform velocity during outstroke and uniform acceleration and retardation during return stroke. Then what type of motion during dwell? So the motion of the follower doesn't have any motion at that time, it is in the rest constant. Now for this case, how to draw the displacement diagram? So what is the displacement diagram? Displacement diagram is the diagram of the angle of rotation of the cam versus the lift of the follower is known as a displacement diagram. So here for drawing the displacement diagram there is x-axis and y-axis. We have to consider a scale. Scale for x-axis is, we are going to consider the outstroke is 120 degrees theta O, this is theta OD, and next 90 degrees this is return stroke, and rest of the dwell that is also theta RD, that equal to 90 degrees. How 90 degrees comes? For one rotation of the cam it makes 360 degrees. So 360 degrees minus the sum of outstroke and dwell and return stroke angles, that gives the return stroke dwell, that is 360 minus theta O, 120 plus 60 plus 90, so 270. 360 minus 270, that is 90 degrees. So this theta RD is 90 degrees. Now take x-axis, the scale on the x-axis considering conveniently 20 degrees equal to 1 centimeter. Why consider 20 degrees equal to 1 centimeter? Outstroke is 120 degrees. We can divide the displacement diagram into even number of parts, that is 6 even number of parts. Then theta O comes 120 degree, that is as 6 centimeters. Theta OD, that is 3 centimeters. Theta R 4.5 centimeters, that means it is 90 degrees, 90 by 20 degrees. So it is 4.5 centimeters. Theta RD again 4.5 centimeters. Alright. Next, draw a line which is having a length of 18 centimeters and draw a vertical line with a length of 50 millimeters, that is 5 centimeters. Divide these horizontal lines with the partitions with the lengths of outstroke, dwell, return and return stroke theta RD. This is the theta O outstroke portion, theta OD portion, theta R portion, that is theta RD portion. Now divide this, then draw vertical lines with the top horizontal line. Divide this outstroke and return stroke. Here it may seem that outstroke should be more length, but I am using manually. The procedure is that it comes as 6 centimeters, so it will be more than the return stroke. The return stroke is 4.5 centimeters. Okay, I am doing manually, but it is, you can divide. The procedure is that you divide this outstroke into even number of parts. Again, join this vertical lines with this even number of parts divisions. Similarly, return stroke also you divide into equal number of parts. Now, mark this division lines 0, 1, 2, 3, 4, 5, 6. Similarly, it is 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and it is 0 dash. Now, outstroke is uniform velocity. These are top portions P and Q. When the motion is under uniform velocity, so it is a straight line. Join O to P. Join O to P. This is the outstroke portion and it is PQ. When outstroke is uniform velocity, the displacement curve for outstroke is OP. The one is intersecting, this vertical and inclined line is intersecting, this is a point A. You mark it as point B, it is point C, and it is D, point E, and it is P. So the displacement during outstroke of the follower is the vertical rising. And the first 20 degrees of rotation, this is 1 to A distance. Next 2B, next to 20 degrees. Next to 20 degrees it is 3C. Next to 20 degrees it is 4D. Next to 20 degrees it is 5E. And next 20 degrees it is 6P. Now the point is that this is the uniform velocity diagram. Okay, when the curve is under what? When the curve is under the motion of uniform velocity. Now, return stroke is not uniform velocity. It is not a uniform velocity during return stroke. It is uniform retardation. Retardation means coming down. So, how to draw the displacement diagram? Now, divide the center portion of 3 dash line into equal even number of parts. That is 6 even number of parts. Join this Q, okay, with the center portion. Join this Q with this. Now you market this center portion into different parts. This point E dash, because it is E on the other side, I am same marking it is D, means D dash, C, C dash, B, B dash, A dash. Now join this D dash and C dash. Similarly, from bottom corner, join A dash line with the corners. Now, this 1 dash is intersecting at this point. 1 dash and A dash, 1 A dash. 1 dash and B dash intersecting 2 dash at this point. And C dash here. Next to 4 and intersecting with the D dash line here. Next to 5 and E dash intersecting at this point, vertical line. So join all these points. That locus of the path of the curve is the uniform retardation curve of the follower during return stroke, which is having uniform retardation. This is the curve. Trace. This is the uniform retardation curve, and the rest is the developed zone. So in this manner, we have to draw the displacement curve. When the follower is having uniform velocity during outstroke, and when the follower is having uniform retardation during return stroke. So this is the combination of uniform velocity and retardation motion of the follower. Suppose whatever follower may be, if the follower is knife edge follower or roller follower or flat faced follower, the displacement curve remains same. But the displacement curve is dependent on two parameters. Number one, type of motion. Number two, lift of the follower and the angle of rotation of the cam. And also third parameter is the lift of the follower. Here the lift of the follower is, what is the lift of the follower? The lift of the follower is 50 millimeters. That is y-axis. The height, the height is 50 millimeters. Okay. Next, this is the one case. Similarly, next second case I am going to consider it is that during return stroke, it is uniform retardation, and during outstroke, it is a simple harmonic motion. Then what type of displacement diagrams comes? Then we have to draw the displacement curve, the displacement during outstroke, we have to draw the simple harmonic motion, and return stroke, it is remains same what you have drawn, that is retardation, same thing. Now, outstroke, it is SHM, simple harmonic motion. And return stroke, theta R, the return stroke, theta R is uniform, having a motion of uniform retardation. Uniform retardation. How to draw the case? Again, we have to draw. Again, take a scale on x-axis, and 20 degrees equal to 1 centimeter we considered here. You can take it 10 degrees equal to 1 centimeter, or the less scale if you consider, the size of the displacement diagram will be increased. So take optimum scale such a way that in answer script you should not cross the beyond the width of the A4 size sheet. And you can draw horizontal also, you can keep it, but make it and time consideration also. Now how to draw that curve? Now here it is, we are considering the, again draw x-axis scale, draw the first step and divide the x-axis into the portions of outstroke, dwell during outstroke and return stroke, and dwell during return strokes. Divide outstroke into even number of parts, that is again 6 parts we considered. Then what is the next step? During outstroke, it is simple harmonic motion. When it is under simple harmonic motion, divide the vertical lines, lift of the follower, and draw a center line. With this center, draw a semicircle. Divide the semicircle into 6 number of parts because we divided 6 portions on the outstroke. Similarly, 6 angular divisions. This 0, 1, 2, 3, 4, 5 and 6. Now, draw a horizontal line from this angular divided on the surface of the semicircle. From that, draw a horizontal line and intersect the vertical one line. This is the point. Next, from 1, it is a point. From 2, draw a horizontal line, intersect, set 2 vertical line. Again 3, similarly 4, similarly 5. Now, these are the portions of what? Points, path of the follower during outstroke, which is having simple harmonic motion. Now, join all these points with a smooth curve. So, this is the SHM curve during outstroke. On return stroke, it is the uniform retardation. This is the curve when the follower is having SHM during outstroke and retardation during return stroke. So again, the height, the raising of the follower for a particular angle of rotation. Here outstroke is 120 degrees. The outstroke 120 degrees is divided into 6 equal number of divisions. That means each portion indicates the 20 degrees of cam rotation. But even though the linear scale is how much? 1 centimeter, 1 centimeter here. For 20 degrees of cam rotation, it is rising. How much it is rising? For first 20 degrees, 1 to A. 1 to A is the portion. Next 20 degrees, it raised from A to B height. That is 20 degrees. From again 3 to C. 3C is the distance for next. That is how much? From 0 to 3 it is 60 degrees. For 60 degree of cam rotation, the rising of the follower is the distance from 3 to C. And next 20 degrees, the rising of the follower is 4 to D. For the next, it is 5 to E. For the next, it is 6 to P. So this 6P is the maximum distance or maximum rising of the follower. The maximum rising of the follower, outward stroke, is the maximum is 50 millimeters. Then PQ is the portion where dwelling. There is no rising, neither rising nor falling or nor returning. The next, it is following the motion of which motion? Uniform retardation. That retardation, it is not 20 degrees. The return stroke retardation is how much? The return stroke is 90 degrees here. How much? Divided by 6 equal divisions. That is, each division indicates 15 degrees. So next, so 120 plus 60, 180, 180 plus 15. It comes down this portion. This is the zone of falling the portion. So it comes down. Finally, up to next 180 plus up to 270 degrees, it's coming to rest. From 0 degrees to 120, it is rising. And 60 degrees, it remains same. That is 180 degrees. Next 90 degrees is coming down. So, the outstroke angle is greater than the return stroke. When the outstroke angle is greater than the return stroke, the time taken during outstroke, the time of outstroke is more than the time of return stroke. So, if we correlate this mechanism to quick return motion mechanism, the time of cutting stroke is larger there compared to the return stroke. That's why the time cutting ratio, time of cutting to time of return is greater than 1. Similarly here, the ratio of time of rising to time of return or time of outstroke to time of return stroke is greater than 1 in this case. Why? Because the time of cutting is there more, because cutting takes place more. But here the time of outstroke to time of return stroke, it is dependent upon the angle of rotation. Here the outstroke angle theta O, that is 120 degrees, whereas return stroke is 90 degrees. So the time takes rising is more and it is 90 degrees. Rising is more. Why I am telling here? Because here it takes, because more angle rising takes more, the more angle of rotation of the cam, that is 120 degrees, that is 30 degrees more than the return stroke. Okay, and the dwell also, it is equal to return stroke. The dwell during return stroke after next to the return is 90 degrees. So, but dwell next to outstroke is how much? 60 degrees. Here, there are two dwells are there. One is dwell next to outstroke, another one is dwell next to return stroke. The dwell next to return stroke is more than the dwell next to outstroke. So, it is, you can understand here, how much time it is opening and dwelling is low and return is low, and here after next to return is high, that is 90 degrees. So this is the angle of rotation. This is the displacement diagram of the follower when it is having simple harmonic motion during outstroke and follower is having uniform retardation during return stroke. For this, this is the displacement diagram for this case study. Now, these are the different types of diagrams we can go on. So, principle is that, very important principle is that we have to understand the type of motion of the follower during outstroke and return stroke is the same or not. If it is same, the same simple harmonic motion curve continues. And if it is different, we have to follow the type of motion of the displacement diagram portion and we have to draw. So, in this manner, why? Because it affects the profile of a cam. Okay? It affects the shape of the cam. It affects the geometry of the cam. Geometry of the cam also affected by not only angle of outstroke angle, return stroke angle, dwell and dwell during return stroke. It also affects the type of motion of the follower. If the type of motion of the follower is only uniform velocity, it is a different shape. It is only uniform acceleration retardation during outstroke and return stroke, it is different. And it is only uniform acceleration retardation, it is different. And if the combination is there, it is entirely different. These are multiple combinations we can go on explaining. Okay. But principle is that we should be very careful what are the conditions given for drawing the cam profile. Outstroke, what type of motion? Return stroke, what type of motion? We have to carefully understand. The next important parameter or important condition is that whether the axis of the follower is passing through the axis of the cam or not. If it is passing through the axis of cam, all the lines are radial lines. If it is not passing, offset lines you have to draw. Those offset lines are means tangential lines, tangential to the offset circle. Okay, and for it is the type of follower, the roller follower, we have to draw a prime circle. On the prime circle, we have to passing through these tangential lines, passing through the prime circle divisions. And there on those lines, tangential lines, we have to trace, we have to mark the trace points of the roller, centers of the rollers. Those centers of the roller are the tracing points. Okay, and we have to draw a curve by touching the surface of the roller followers. Okay, not the centers. Okay, like that we have to change, and depends upon various conditions, different designs of the cam profiles comes. Okay, and this is one type of drawing the cam profiles. Next is that if the cam profiles are having a speed of with a constant speed and having a motion of uniform velocity is there, then we have to find out what is the maximum velocity of the cam. Suppose if it is having a uniform acceleration and retardation, then we have to follow again what is the velocity, maximum velocity, and what is the maximum acceleration during outstroke. Similarly, during return stroke, what is the maximum retardation? Because these are the kind of maximum velocity and maximum retardation during return stroke and during outstrokes also. So it comes under again what is the displacement of the follower. From that, what is the maximum velocity, what is the maximum acceleration of the followers. That is related to the follower concept. So like that we have to go for in order to do design and study the various parameters, especially displacement, velocity and acceleration of the follower, and also in order to get the different various designs of the cam, how the parameters are affecting. So each and every parameter, input parameters are so important in order to obtain or draw the cam profile. And we have to use geometry instruments. So then only we can get the shape of a two-dimensional shape of a cam. Okay. And next, very important certain terminologies in the case of cam profiles. The cam profiles, the terminologies are: what is the base circle? Is the number one. Next term is the prime circle and lift of the follower. Okay. Next one, offset circle. Pressure angle. Tracing point. And cam profile. Okay. And the next one is various points are there, various terminologies we have to learn. Prime circle curve. So these are the different terms we have to know while drawing the cam profiles. Then we can draw the exact shape of a cam. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.